Assalamualaikum warahmatullahi wabarakatuh and very good afternoon to Doctor. We are from Group 8 and we would like to share about C chart and U chart. So my name is Muhammad Haikal bin Fazil. I would like to share about C chart. What is a control chart? Control chart is a graph used in production control to determine how a process changes over time and whether the quality and manufacturing processes are being controlled under stable conditions. Control chart is such a graphical representation of whether a firm's products or process which can be meeting their intended specification. Mostly companies use control charts to analyze a specific attribute of a product, which is called multivariable chart. So what is a C chart? The C chart is used when trending the number of defects per subgroup in a constant sample size. So mostly C chart can be such some purpose to help determine if a process of stable and in control or unstable and out of control. So next. Okay, based on this diagram, we can see there is two types here. The first one is defect and the second one is defective. So a defect is an undesirable condition within a unit, while defective is an entire unit that fails to meet specifications. If a unit has a defect on it, it is a defective unit. So a single defective unit can have multiple defects. So we look at the C chart. C chart is mostly used for constant sample sizes, and then while a U chart is used for a variable sample sizes. C chart can be find some specific causes of variation to reflect the process improvement, and about the U chart, which is used to evaluate variation in a process where measurement is a variable on a continuous scale. So the C chart is mostly like for the constant sample size, and the U chart for the variable sample size, or each called different sample size.
Okay, now we'll be resuming in the formulas. So the formulas are simple. So there will be three formulas, which is the formula for center line, the formula for calculating the control upper limit, and also the lower control limit. So for the upper control limit, the equation is the sum of all defects over the number of subgroups. So for the upper control limit, you just need to add in the center line plus with the cube root of the center line, while the lower control limit is the same, but the difference is it is in minus. So this is the example, one of the questions for the C chart. So if you can look at here, the lot size, which is the sample size, is all in constant. That is why C chart is categorized as a constant control, quality control. So using the equations, we just add in all the count of defects and total it up, and it will be 95. So we sub it in to the equation. 95 over 20. 20 is the number of subgroups, and we will get 4.75 defects per subgroup. And to calculate the upper control limit, the C bar plus the cube root, and you will get 11.29, while the lower control limit is 0. It is not negative 1.79 because the lower control limit can't be in negative, so it has to be 0. So this is the example of the C chart from our example just now. So the low control limit is 0, the upper control limit is 11 point something, and you will get this type of graph. So what if the C bar is lower than 2? So if the C bar is lower than 2, the control limit equations, which is the three equations that I just showed you just now, are not valid. In these cases, the control limit must be derived from the Poisson distribution. The Poisson distribution. The C and U charts are based or approximated by the Poisson distribution. If C is sufficiently large, the Poisson distribution is symmetrical and approaches the shape of a normal distribution. In these cases, the equations for the control limit, the C and U chart are valid. However, if C is small, the Poisson distribution is not symmetrical and the equations are no longer valid. The figures below that I will show you in the next slide will demonstrate on how the shape of Poisson distribution changes as C bar increases from 0.5 to 10. So this is the example of the graph of Poisson distribution. So if you can see here, the C bar, if it is lower than 2, C bar is 1 and C bar is 0.5, the graph will not be symmetrical. Whereas if the C bar is higher than 2, such as 5 and 10, it will look symmetrical and it will be in a nice Poisson distribution shape. That is all from us. Thank you.
Next, we're going to move on to U-chart. So what is U-chart? A U-chart, also known as a defects per unit chart, is a type of statistical process control chart used to monitor the number of defects or non-conformities in a sample of items or units. It is typically used in manufacturing or quality control applications to track the performance of a process over time and identify any trends or patterns in the data. The U-chart is similar to the P-chart, but is used when the sample size varies from one subgroup to another, while the P-chart is used when the sample size is constant. Next one is a statistical tool called a U-control chart tracks process flaws or nonconformities over time. In cases of fluctuating sample size or uncontrolled procedure, it is advantageous. The U-chart models the number of successes in a fixed number of trials using a binomial distribution. In a U-chart, the sample size is trials and the number of success is faults. Data is gathered over time and sample faults are recorded to create a U-chart. Control limits depend on the sample size, thus it's documented. The average and standard deviation of sample faults are used to determine control limits. The U-chart is shown with flaws on the y-axis and time or sample number on the x-axis. And also the U-chart helps reveal data trends like defect increases or decreases over time. It can also find outliers or unusual variability. In conclusion, the U-chart is a great tool for tracking process, flaws, or nonconformities. In cases of fluctuating sample size or uncontrolled procedure, it is advantageous. It helps find patterns and outliers. So, what is the most important things for U-chart? A chart is a graphical representation of data, often used to display data in a clear and concise manner. Some important details to consider when creating a chart include. So for the first point is the type of chart that best represents the data. For example, bar chart, line chart, pie chart, and etc. For the second one is the data. The data that the chart should display and how it should be organized. And the third one is the scales and labels for the x and y axis. For the fourth one is any additional elements such as legend or data labels. For the fifth, the overall design and layout of the chart, including colors and font choices. And the last one is if it is for a presentation or a report, the context and audience the chart is intended for. So it's important to remember that the charts are a tool to communicate information And the key is to communicate it in a way that is easy to understand. So what's in U chart? So the first one in U chart is number of defects, which is C, and sum of defects. For the next one is sum of sample size, and the other one is number of lots, which is K for the symbol, and sample size, which is for the symbol is N. So for the number of lots and sample size can only be used when the value of sample size is same. For example, K is for 20 and N is for 100. And the last one is center line, and this is the equation for the center line. We can see this is the upper limit UCL and the lower limit LCL. So how to make a U-chart? To create a U-chart, a sample of items is taken at set intervals, and the number of defects is counted. The data is then plotted on the chart, and control limits are calculated. The control limits are typically set at 3 standard deviations from the mean, but this may vary depending on the specific application and the level of precision required. The U-chart can also be combined with other control charts, such as the P-chart or the C-chart. It is to provide a more comprehensive view of the process. A U-chart is also called a count per unit chart. It is not only used in manufacturing, but also in service industry as well. It can be used to monitor the number of complaints, accidents, or error in the process.
Okay, let's move to the next part on how to make a U-chart. First one, we need to take a sample, and after that we need to count number of defect. The next part, we need to find U, U bar, upper control limit U, and lower control limit U. Next, we can plot the chart. After that, we can find the cause of the defect. This is first example. This sample has 20 lot, and this sample has different sample size, and beside that is the number of defect. The first one we need to do is we calculate the value of U, which we can see in the blue box. To calculate the value of U, we need to take C, number of defect, divide by sample size. After that, we can calculate the value of U bar. The U bar should be the same. And then we can calculate the value of UCL U and LCLU by using this formula. Take a note that the value of UCL and LCL is different because the sample size is different. Hence, we get this U chart. This is different than what we learn, because usually we learn UCL, upper control limit, U and upper control limit and lower control limit is a straight line, but this time we have different lines. This is because the sample size is different. So we observe the chart, we can find one point that surpass the upper control limit. So we need to take that point and we need to calculate the new U bar by using this formula. After that, we need to find what are the causes of this 8, the sample size number 8 to occur. This is the second example. In this example, it is different than before because this one the sample size is same and this one is a little bit easier. We have 20 number of lot and sample size 100, and this is the number of defect. So the first one we need to do is calculate the value of u for each one. C, number of defect divided by sample size n. In this particular example, we have same sample size. We need to find the u bar using a very easier formula. The formula is summation of C, which is summation of number of defect divided by sample size, which is 100 multiplied by number of lots. So we have the total of number of defect, which is 937 divided by 20 multiplied by 100, we got 0.4685. And for the upper control limit and lower control limit, the value is the same, so we just calculate it just for once, not like before this. The value of each lot of UCL and LCL is different, but this one is the same. This is the result of the U chart. We can see the UCL and LCL is straight line, and in this particular example there is no point that surpass the upper control limit or lower control limit. And that's all from us. Thank you.